How weathered are the Voyagers by now? Did we already start building the Dyson sphere? What should we expect from the extremely large telescope? And in Q&A Plus, why do we prefer L2 Lagrange point for our telescopes? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Solar cloud. Is Parker doing well? If so, in theory, do we have the technology and capability to build the starting tech for a Dyson sphere? Parker Solar Probe is performing exactly as expected. It's now reached its final orbit. It has no more flybys that it can do of Mercury or Venus to be able to move it any closer to the sun. And so it's sort of in this final orbit that brings it really close to the sun. It's gathering a bunch of information and then flies back out and then cools down and dives back in and heats up. And, it will operate for the rest of its primary mission. And then NASA will take a look at the health of the spacecraft and decide how well it's doing and then continue on this process. When it's out of propellant, which is usually kind of the death knell for all of these kinds of satellites, then they will do something that's really interesting, which is that they're going to then turn the spacecraft so that its heat shield is no longer protecting all of the instruments. And then they're going to let the radiation and the heat from the sun start to ablate the instruments on board the spacecraft, destroy them, and keep track of what happens to the instruments as they're getting ablated, how long they last, what kind of radiation tolerance can they have. And that will allow future spacecraft that will be in sort of high temperature environments. They'll know what the various metals, the glass, the instruments can handle across the entire spacecraft. And then Parker Solar Probe will be a burned out husk that will be continuing to orbit the sun for forever, really. It'll be the heat shield will be all that's left. So, is this the starting tech for the Dyson sphere? Well, I always say that we've already begun building our Dyson sphere, that every satellite that we launch into space that is harvesting energy from the sun and is doing some kind of work for us, be it science, be it communications, be it human habitation, whatever it is, this is the Dyson sphere. Right? We are preventing radiation that would have gone out into deep space, that we are now collecting it and capturing it here for our purposes, either using it in space to run the operations of the spacecraft, or we are bringing it back down to Earth. It's just a matter of scale, right? And so, every year that goes by, we will have more satellites. We'll have more satellites for sure. Right now, whatever, it's 1/4,000th of the sun's energy is being blocked by machines from humanity. But maybe next year it'll be 2/4,000ths, and maybe in 100 years it'll be 1%, and then in 1,000 years it'll be 10%. And so you don't just go, now we're building the Dyson sphere. It's more that you just build more and more satellites to harvest more and more of the radiation that's coming from the sun. In the same way that you look at a forest and say, if you're harvesting the lumber from a forest, you cut down the trees one at a time until you've cut down the trees in a responsible way, making sure that they're wildlife corridors and you're not infringing on the riparian habitats with a sustainable forestry system. But yeah, that's how it goes. So I think, the Dyson sphere has already begun. The moment we launched a solar powered satellite, and I wonder what was the first solar powered satellite? That's interesting. The Dyson sphere construction began. Lothian, is it really a Dyson sphere? It does not provide power to Earth? Yes. Yeah, why does the power have to come to Earth? If you're going to build a satellite that's going to be doing computing, that's going to run enormous simulations that are going to be trying to work out cures for cancer, things like that, you send the raw data up to the satellite crunches all the data for a year, it sends you the result back on Earth. How is that not just an extension of our civilization into space? So yeah, I think very little of the future of really just the solar power that's coming from the sun is going to be used down on the surface of the Earth. And the reality is that you don't want to. That every photon that you send from space to Earth contributes to the warming of the planet. And we already have seen with global warming, just by trapping carbon dioxide in the atmosphere, we are warming the planet. We do not want to compound this with sending additional photons from space down to Earth. We can send information, we can send finished components maybe, but really we're going to be sending stuff to space that's going to be used in space for space things. And maybe these satellites are going to be beaming power to each other, but we definitely don't want to send any of this back down to Earth. And in the sort of most advanced version of the Dyson sphere, you've destroyed the Earth as well, right? Like, to make your Dyson sphere, eventually you dismantle Mercury and Venus and Jupiter and all these things to fully control. And maybe people are going to go, well, do we really need Earth anymore? Yes, you need Earth. Don't do it. Don't destroy the planet to build your Dyson sphere. You're bad people if you do that. But this is a thing that some future civilization might decide they want to do. Paul Wilson, do the Voyager probes look weathered from their space journey, or do they look clean like new? It's an interesting question. And obviously we can't know the answer to that question because we can't see what the Voyager spacecraft look like. Now, we can see that spacecraft that are in low Earth orbit do look weathered. We see little sort of pits and pockmarks and things from bits and pieces of debris. We know there's a ton of even just like small, like 1 gram pieces of material that are in orbit around the Earth. Some of it is from space, much of it is human caused, and this causes a weathering that happens to any spacecraft. Whenever you see, say, the space shuttle, there were like pocks and dings in the windscreen. And some of them are like a little concerning. And when you see the solar cells on the International Space Station, same thing. You see little pockmarks and dings and blemishes from the various space junk and just micrometeorites and stuff that have hit the station. And we know that the James Webb is being hit by small micrometeorites. One was fairly big and in fact caused people operating James Webb to kind of change its orientation just to minimize the number of those hitting it. And so the Voyagers have been going for 50 years. They have absolutely gotten dinged and hit by various stuff. And if you could look at them, you would see that, in addition to the constant radiation that was coming from the sun that has probably bleached any paint on the surface of it. The amount of weathering, though, is very low. And it's been estimated that the Voyagers, like, you could still read the records on the Voyagers 1 billion years from now. So it's going to take on the order of billions of years for these things to fully weather in space to the point that they're unrecognizable blobs of metal that are drifting through space, as opposed to, like, that clearly was a robotic spacecraft once, one long time ago. But yeah, if you could look at the Voyagers, they had some wear and tear for sure. It's time to shout out all the new $5 patrons and above. The Big Box of Matches, Basil Dahiyat, Space Geek Sherry, Peter Van de Vegt, Bob Hartlub, David Pollard, Robert Piparo, Ryan Amari, Kira, and Ronnie V. Join the club at patreon.com/universe today. Mad Million, the Extremely Large Telescope. What breakthroughs do you expect from it once online? So the Extremely Large Telescope, this is a ridiculously big telescope. I know it's called the Extremely Large Telescope, but I think it should be called the Ridiculously Big Telescope. It's a 39-meter telescope that is being built in Chile right now. And when you compare, like, the biggest telescope on Earth, there's a telescope in the Canary Islands that's 10 meters across. The current, essentially most powerful network of telescopes is the Very Large Telescope, which is a collection of 4 8.2 meter telescopes, as well as a couple of other smaller telescopes. There's the Large Binocular Telescope that is 2 8-meter telescopes side by side. This thing is just ridiculous, 39 meters across. And it's under construction now, probably will be finished construction 2027, 2028. And then it should be able to come online. And it is going to be a general tool for astronomers. It's got a bunch of really interesting instruments on board. It's got this enhanced version of the adaptive optics system that we see on the smaller telescopes. And I love sort of when you see animations of what this thing is going to look like. There are all of these lasers pouring out of this observatory. And so it's going to be able to generate multiple guide stars in the sky in the field of view that it can use to then adapt the mirror shape to compensate for the atmospheric distortions. And so it will be as if it is in space. It's as if we launched a 39-meter telescope and we put it out into space. Which is incredible when you consider James Webb is 6.5 meters. Like, this is a monster. And it will be so good that it will be able to do things that astronomers have just, like, hoped for a long time. Like, it should theoretically be able to distinguish an Earth-sized world orbiting around a sun-like star in perfect conditions. It should be able to detect the presence of gas giants and things like that orbiting around stars more like the sun. And then it would just be used in this way that all telescopes are used, to examine galaxies, to examine protoplanetary disks, see new regions forming around them. I mean, it's just like what do you use a kitchen for, right? You use it to prepare all food. And so this thing is going to be able to be used for everything that astronomers need visible light telescopes for. It's going to be a monster. I cannot wait. And it's kind of interesting to see, like, the budget of this telescope is a little over €1 billion, like €1.5 billion. And you just compare that to the prices that it's cost. You know, James Webb was $10 billion US dollars. Other telescopes are in the multi-billions of dollars. And yet these gigantic monster telescopes are reasonably priced. And so it just shows you the advantages of building ground-based telescopes compared to space telescopes. That said, here we are in this era where there are now, 10,000 satellites, that the field of view is getting dimmed every day. And that we might get to this point where there's 1 million satellites in orbit around the Earth. Yikes. So unfortunately, the utility of ground-based observatories is growing less and less every year. Stephen Lewis, shouldn't we be sending robotic scouting and landing site preparation missions to the moon now instead of rushing to send people? One death would be a major setback. Well, of course. Yeah. I mean, this is happening. I mean, that we have the entire NASA commercial lunar system where they are paying various commercial companies to deliver scientific payloads to the surface of the moon. And, this is something that used to be done by entire space agencies. And now NASA is, the budgets of these spacecraft is very low. You think about the Blue Ghost, like the budgets are in the tens of millions of dollars to deliver a payload to the surface of the moon, which once cost $1 billion. So we're in this new era, and in preparation for the Artemis mission, which in theory is going to land humans on the moon in 2027, but come on, or the Chinese are going to land humans on the moon by 2030, that you are going through the process of the robotic testing. I think, the Chinese one is probably a better example to sort of show how this is being done in a very painstaking manner, which is that, the Chinese are up to Chang'e 5. They've sent several landers to the surface of the moon. They started with just a simple lander, rover, and then they went to sample returns and more sample return from the far side of the moon. And now we're moving into in situ resource utilization on the surface of the moon, leading up to humans landing on the moon. That all of the technologies are the same. You have a big rocket, it carries a payload to the surface of the moon, lands safely, people do some things, they get on their ascent vehicle, they meet with their capsule, they come back down to the Earth. This is what happens with the sample return from the moon for the Chinese spacecraft. And so, all of these steps, all of the uncertainty, all of the risk that you're describing in your question are the kinds of things that people who are doing mission planning are thinking about. And that whenever human lives are on the line, you need to take that very seriously, and you need to be more careful, and you need to flight test the hardware that is coming before that. And that's, and that's why I think I made my skeptical come on earlier on in this question, which is that the US plan for sending humans to the moon is going to be relying on the SpaceX Starship as the human landing system. But we still have not seen Starship go to the moon, land safely, go back into orbit, demonstrate that it can be the landing system. Now, it probably can and probably will, but it's going to take some stages and some steps and some development. And then you're also seeing Blue Origin go all in on its lunar landing plans, but they have not demonstrated that they can send their lander to the surface of the moon yet. Like, this is all theoretical. And so if the US's plans to land humans on the moon is depending on hardware that has not been flight proven, not demonstrated to do the job that it's required, then we will expect delays. But we have learned from the history of human space exploration that whenever you cut corners, whenever you ignore the obvious warning signs that your spacecraft is not ready to go, then you risk a potentially deadly result. We lost 3 people in Apollo 1. We lost 7 people in the Challenger. We lost 7 people in Columbia. That is a lot of people to lose in just trying to go to space. And any deaths, any injuries will cast a long shadow over the future of lunar space exploration. Jimmy Rowe, isn't there mold on the space station? Like a lot of it? Yeah, so there is definitely mold on the International Space Station. And this is because you've got a closed environment that has human beings that are breathing out water vapor. The water vapor collects on various surfaces in this environment that has weightlessness. And then it's warm, right? It's always warm inside the International Space Station, and that is the perfect environment for mold to grow. And so the downside of being an astronaut, and this is like the unromantic part of being an astronaut, is that you spend a lot of your time in maintenance on the station. They are constantly cleaning, wiping down surfaces, testing the air quality to make sure that it's safe for them to be able to breathe. And they have to deal with these kinds of issues all the time. And that astronauts spend a huge chunk of their day exercising, cleaning, maintaining equipment, just to then be able to spend half an hour doing some kind of science experiment or watch a DVD or enjoy a meal with their comrades before they pass out and start the whole day all over again. That it sounds glamorous. Yeah, you do get to look outside the window in the space station, but the downside is that you're constantly trying to maintain this complicated machine that is flying in orbit. And there's been a ton of really interesting research about the kinds of life forms that exist on the space station. You have this laboratory where you've got bacteria, you've got mold, you've got other organisms that have gone to space with the astronauts and are now living on the station. They're exposed to different kinds of radiation. They're experiencing weightlessness, and this is causing their genes to express in different ways, different kinds of advantages and disadvantages, because it's an evolutionary environment. And they're constantly bringing samples back home to Earth and analyzing them and studying them and finding the new things that they do, and then trying to run experiments that actually maybe put those things to use. They're finding like various antibiotics grown in space have different behavior, or bacteriophages grown in space, which are viruses for bacteria. They have different advantages against different kinds of bacteria than the ones that are grown on Earth. So the downside is, yeah, you have to clean up mold. And I think, from what I understand, being on the station, it smells very musty. It smells like you're inside a locker room, despite the best efforts of the astronauts to keep the place as clean as humanly possible. Probably smells like bleach and locker room. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. This week's bonus question: why do we prefer the L2 Lagrange point for our telescopes? Now, I'll put a link in the show notes so you can watch that episode right now. All right, those are all the questions we had this week. Thank you, everyone who asked your questions in the YouTube comments, everybody who joined me for the live stream. Now, we do the live stream. It's 2 hours long. The next one is going to be Sunday, March 1st at 10 p.m. Pacific time. We do that so that the people in Asia will be able to watch it in the afternoon. So we rotate the time of the question show. So that's when the next one is going to be. Now, I'm going to answer a question that you may have been wondering about, which is, why is my YouTube channel my name and not Universe Today? Get to that in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielak, Cooper Nelly, Darkfinga, David Giltonen, David Matz, Evan.pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Mike Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Rank Haidu, Richard Williams, Sean Sargent, Stephen Filamunley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means universe to us. Pitchwheel asked in the comments, why is your channel named after you, and why is it not called Universe Today? And that's a very reasonable question to ask. Why is my channel name my name and not Universe Today? And the answer is probably a little unsatisfying, which is that I started up a YouTube channel, like we all did, to watch videos. And so I started up the channel, and if you go all the way back to the very beginning, I think I did a time lapse with my kid where we made the dishwasher clean itself or something like that. And then we also did some Lego animations, but maybe they're not still on the channel. And then I really wanted to try doing my own YouTube videos. around 2012, but it was going to be just like an experiment. I was just going to try out explaining some concepts in space and astronomy and have it be its own separate thing and see if I could sort of gain this skill. And again, you can kind of go all the way back to the beginning of the channel and you can find a video of me hunched over in bad lighting with a bad camera explaining why light takes 8 minutes to get from the sun to the earth. And then it just kind of kept going. And so I just kept using that channel, my personal channel, the Fraser Cain channel. And we actually did set up a channel for Universe Today. I think it's Universe Today Vids on YouTube. And we use that as a place to upload videos that weren't already on YouTube. Like if there was a video associated with a story, we would, and there was no place that we could just embed the video, then we would have to download it from, say, NASA, put it up to YouTube and then embed it that way. But we don't really use that channel very much. And over time, I had this realization, or this awareness, growing awareness that you actually want to have a personality behind the news, behind the channel, behind what we're doing. That having a kind of brand identity for Universe Today is less effective than having it be my personality. You know, I am the publisher of Universe Today. I am sort of the person who runs the show. And so it made sense for me to connect myself to the channel. And now I think it's more important than ever. I mean, we're getting the AI slop that's showing up, that you've got all these nameless, faceless channels. You've got these generic voices. No one really knows who's behind anything anymore. And I think people really want to know if there's some personality, somebody who they can trust. And so in retrospect, I actually think that was a good thing that I did, that I just kept building on my personal name and then trying to remind you every time that I can that I also do Universe Today. And there's plenty of people who have no idea that Universe Today is a website and then I run it, or that I am the co-host of the Astronomy Cast podcast. But it would be easier, I think, than getting people to know about the Universe Today YouTube channel and then people realize who I am and that I'm associated with it and that it's, you know, names that you can trust. But I mean, other people have done this as well. I mean, I look at, say, The Verge, you've got Neil A. Patel, you've got Linus Tech Tips. Of course, his name is in it. So there you go. So in retrospect, I think it worked out as the right way to do it. And, you know, anyone who is trying to like hide behind a nameless, faceless channel at this point in this economy, you've really got to show your personality and who you are if you want people to, I think, take you seriously. All right. We'll see you next time.